Dear students, this is another video for the playlist Liquid. It's Liquid lecture number 2. In previous video, I told you about intermolecular forces and I told you the types of intermolecular interactions, which are hydrogen bonding, dipole-dipole interaction and London dispersion forces. However, in this video, I'm going to deal with dipole-dipole interaction. If you haven't seen those videos, that first lecture, then I'm writing down it in the description box. You may just check it out before this video. Okay, the word dipole interaction. Just focus on this word dipole, like having two poles, and two pole will be created because of some differences. Okay, here you can see that pole has been created, and these pole have been created because of the difference in electronegativity. Okay, so the main thing which cause the differences or the pole to create this is electronegativity difference, and that electronegativity difference creates two poles inside a molecule by making a dipole-dipole interaction. Here you can see that dipole has been created in a molecule because of difference in electronegativity. Dipole-dipole interaction are type of intermolecular attraction between two molecules. Okay, because we know that we are dealing with intermolecular attraction, so it will exist between two molecules. Dipole-dipole interaction are electrostatic interaction between permanent dipole of different molecules. Okay, these are electrostatic interactions. Dipole-dipole interaction are electrostatic in nature. Always you must remember in the physics as well that whenever there is a charge distribution like positive and negative, the force of attraction that will exist in between them will be electrostatic in nature. And ionic bond is also an electrostatic force of attraction. You will learn later about ionic bonding, covalent bonding, etc. These molecule interaction align the molecule to increase the attraction. Whenever this kind of attraction is present inside a molecule, that molecule will have a higher boiling point and will have polarity and will increase the attraction with each other. Okay, the molecule that contain dipole are called polar molecule. Water is very polar in nature. You might have learned that before this video that water is polar in nature and polar get dissolved in polar. Polar molecules always have some dipole because they have differences in electronegativities. Like water has a large permanent electrical dipole. The electronegativity difference between oxygen and hydrogen is very big, as they have quite big difference of electronegativity. So the partial positive charge come on hydrogen and partial negative charge come on oxygen. As a result, dipole is created and which cause the further attraction in the other molecules. It behaves like a few equal and opposite charges separated by a small distance. Like that, the molecule of water will attract each other. This positive will be hydrogen and this negative will be oxygen, and the two molecules of water will be attracting each other. As well, they will increase the boiling point and melting point, etc. These dipole interactions give water many of its properties, including its high surface tension. You might have seen that water has a quite good surface tension and good surface on the upper side because of the dipole interaction, which is present, which give water a good situation and a good surface. Okay, uneven distribution of electrons. What is the reason for dipole-dipole interaction? Why a molecule can be converted into a dipole? How dipole can be created? What is the reason for the dipole? Is the thing that there is uneven distribution of electron. The negative part is having more electron and the positive is having less electron. The permanent dipole is water. Why water is having permanent dipole? Which is that it is caused by oxygen's tendency to draw electrons to itself. Okay, the oxygen is very powerful. It is having a very strong tendency to carry out or to attract the electron toward itself. It's more electronegative now. so it will attract the electron more toward itself. So 10 electron, if there are 10 electron in water molecule, so 8 will be toward the oxygen, or that will be closer to oxygen, and creating a partial negative charge, because oxygen is so electronegative, and the partial positive charge will come on hydrogen. So just have a look on this picture, which is having two hydrogen are bonded with one oxygen. When the two hydrogen are bonded to one oxygen, this oxygen is so powerful that even two hydrogen are attached, it's still having the partial negative charge, it's having most of the electron density toward itself. And this water molecule is another, this dotted line represent, this is dipole interaction. Okay, these strong line or the broad line indicating the covalent bonding. These, like these broad lines now, bold lines, these bold lines are not of dipole moment. Dipole attraction or dipole forces are always represented by dotted lines. When you will see hydrogen bonding, it will also be represented by dotted lines. You will see dipole interaction, that will also be expressed in the form of dotted lines. So this is an attractive force that exists between the two molecules. Let's just check some example of dipole-dipole interaction. This is HCl. We also know that there is a difference of electronegativity between hydrogen and chlorine. So that will create some electronegativity difference, and to look at here, dipole is created. When dipole is created, so dipole force will also be created between the two molecules. Okay, that's why it exists in different situation. Two hydrogen chlorine chloride molecule displaying dipole-dipole interaction, the relative negative chlorine atom is attracted to relatively positive hydrogen atom. So always the negative part of one molecule is attracted to positive part of other molecule. Here the HCl is so positive, negative always attract na. There will not a situation that negative will create a dipole interaction. No, always positive and negative will create, of two different molecules will create a dipole interaction. Okay, so HCl, two molecules of HCl are creating a dipole interaction in which the chloride ion of HCl is attracting the hydrogen ion of other molecule. Okay, so just what are they saying? They are saying another example of dipole-dipole interaction can be seen in HCl. Relatively positive end of polar molecule attract the relatively negative end of other molecule, as I told you. Okay, so this was all about the dipole-dipole interaction. I hope this point was clear. However, there are some molecules that do not have dipole. Okay, so dipole not is a property of every molecule. Dipole is a property of only polar molecule. Non-polar molecule will have no dipole, will have zero dipole. Molecule often contain polar bond because of electronegativity difference if they are symmetrical. Okay, there are molecules that do not contain dipole moment, they do not have dipole forces because they do not have separation of charges. Always remember that most of the organic compounds and most of the hydrocarbons are non-polar. They are non-polar and they are not having dipole force of attraction. CCl4, that is carbon tetrachloride. The carbon tetrachloride is a very symmetrical molecule. In the maths you must have learned that equal but opposite in size, opposite in direction forces cancel out each other. Like in maths you do na, that same kind of values, however they are different or opposite in direction. So in the CCl4, the chlorine atom are more electronegative than carbon, and the electron are drawn toward chlorine. Definitely the carbon is little sacrificing one, it's positive one, and chlorine are negative. However, the carbon chlorine dipole cancel each other out. A little bit math is involved here because of the orientation and because of the symmetrical, the molecule is symmetrical, so CCl4 has no overall dipole moment. Always remember the dipole moment or the dipole forces of attraction are attributed to the molecule that are little bit unsymmetrical in nature, whose electrons are unsymmetrically separated. Like here, the electrons are unsymmetrically arranged between the H and Cl. Okay, so this was all about the dipole forces. I hope the point is clear. I hope the topic is clear. If you have any problem, you may comment down and keep following the lectures. The next is coming hydrogen bonding, which is very interesting. So stay tuned, stay healthy, stay safe. Thank you.